The idea of infinity, a term that signifies without end, boundless, limitless, is a concept that has intrigued thinkers and scholars from the dawn of civilization. The roots of infinity trace back to the ancient philosophers. The great mind of Zeno of Elea, a pre-Socratic philosopher, first introduced paradoxes of infinity in the 5th century BC. His paradoxes left the brightest minds of his time scratching their heads, grappling with the idea of an endless sequence. And yet, despite its paradoxical nature, the concept of infinity has found a comfortable home within the realms of science. In mathematics, infinity is a cornerstone, a building block fundamental to calculus and set theory. Yet it is not without its own set of paradoxes. Consider this: is there an end to numbers? On one hand, we can always add one more to any number, suggesting an infinite set of numbers. But on the other hand, this notion contradicts our everyday experience of finite things. Further, the world of physics has also embraced infinity. Think of black holes, entities with infinite density, or the universe itself. Is it finite or infinite? Does it have an edge, or does it stretch on forever? These are questions that physicists wrestle with, questions that are at the heart of our understanding of the cosmos. Infinity also pervades the field of computer science, with the concept of infinite loops, a sequence that repeats indefinitely until a certain condition is met. Yet again, we see the paradoxical nature of infinity at play, as the idea of a process that goes on without end is, in many ways, inconceivable. So we see the concept of infinity, as tantalizing as it is perplexing, has woven itself into the very fabric of science. It is a concept that challenges our understanding of reality, that pushes the boundaries of our knowledge and understanding. Infinity, a paradox, a puzzle, a quandary that science grapples with. Numbers, they go on and on, don't they? But can we truly grasp the concept of an infinite series of numbers? Imagine a never-ending line of dominoes, each one ready to fall into the next. This gives us a sense of infinity in the world of numbers. Just as we cannot reach the end of the domino line, we cannot reach the end of numbers. They are boundless, limitless, never-ending. In mathematics, the concept of infinity isn't a number per se, but rather an idea. It's a concept that represents an unbounded quantity. It's like a horizon that keeps receding, no matter how far you travel. Now let's dive into the realm of infinite series. An infinite series is a sum of infinite terms. It's like adding up all the dominoes in our never-ending line. You might think, but wait, there's no end to the line. How can you add it all up? Well, that's where the magic of calculus and mathematics come in. In calculus, mathematicians have found ingenious ways to handle infinite series. They have developed methods to sum up these series under certain conditions, even though they are technically endless. This is kind of like saying, if I keep adding dominoes in a certain pattern, I can predict where the line will lead, even if I can't physically reach the end. Infinite series are crucial in many areas of mathematics. They help us solve complex equations, understand the nature of functions, and even explore the mysteries of the universe. They are like the compass guiding us through the vast ocean of numbers. But infinity is not just a useful tool, it's also a concept that baffles and intrigues us. It challenges our understanding of the universe and our place in it. It's a puzzle that mathematicians and philosophers have been grappling with for centuries. Infinite numbers, a tool of the mind, a concept that both aids and confounds our understanding. And so we continue our journey exploring the enigma of infinity, one domino at a time. Space, the final frontier, but is it infinite, and what does that even mean? When we talk about infinity in the realm of space, we're venturing into a world that plays fast and loose with our everyday understanding of scale and distance. The concept of infinity applied to space can be mind-boggling, yet it's a cornerstone of many scientific theories. Consider our universe. Some theories suggest that it's finite, with a specific measurable size. These theories often propose that the universe is curved, like the surface of a balloon. If you were to set off in a straight line, you'd eventually find yourself back where you started. In this model, the universe doesn't have an edge, nor does it go on forever. On the other hand, if the universe is flat and goes on indefinitely, then we're dealing with a truly infinite universe. In this scenario, if you were to travel in a straight line, you'd never return to your starting point. You'd just keep going forever. These two models represent extremes in our understanding of space. One paints a picture of a universe that's finite yet unbounded, while the other suggests a universe that is truly infinite. But here's the wrinkle. Even if the universe is finite, it could still be expanding. That's right, a finite universe can grow larger. This concept, known as cosmic inflation, suggests that the universe has been expanding since the Big Bang and will continue to do so indefinitely. So is space infinite? The answer, like so much in science, is that we're not entirely sure. Our understanding of the universe is constantly evolving as we gather more data and develop new theories. One thing is clear, however, whether finite or infinite, bounded or unbounded, expanding or static, space is vast beyond our comprehension. It's a realm where the rules of the familiar world don't always apply, and where the concept of infinity takes on new and strange dimensions. Space, infinite or not, is a mystery that continues to perplex us. Time, it seems to go on forever, but can it? Is there such a thing as infinite time? From the moment we first understand the passing of days, we are introduced to the relentless march of time. It flows forward, never backward, from the past, through the present, and into the future. Yet this linear perspective of time is a construct of human cognition. In reality, time may not be as straightforward as it seems. The concept of infinity applied to time creates an intriguing paradox. If time is infinite, then it has no beginning or end. It stretches out indefinitely in both directions, past and future. But if time had a beginning, as suggested by the Big Bang theory, then it cannot be truly infinite, at least not in the past direction. Physicists have proposed various theories that challenge our linear perception of time. Some propose a cyclic model where time is a loop, endlessly repeating itself. Others suggest a multiverse where time could have different properties in different universes, perhaps even flowing backward. There are theories that imply time might end. The Big Freeze hypothesis, for instance, suggests that as the universe continues to expand, it will eventually reach a state of maximum entropy, a time of no change, effectively the end of time as we know it. The concept of infinity in time is not just a philosophical speculation, it has real implications for our understanding of the universe, from the laws of physics to the nature of existence itself. It's a concept that pushes the boundaries of our understanding, forcing us to question, to ponder, to dream. Infinity is a concept that defies our intuition and challenges our perception of reality. It's a puzzle that has baffled the brightest minds for centuries and continues to do so. The infinite nature of time, its beginning and end, remain among the greatest mysteries of science. Time, infinite or finite, is a riddle that challenges our understanding of reality. Infinity, a concept that both enlightens and mystifies. But why does it matter? We've journeyed from the infinite numbers that stretch beyond comprehension, through the expanse of space that seemingly has no end, to the endless flow of time. These are all facets of the grand puzzle of infinity in science. It's a concept that pushes the boundaries of our understanding, forcing us to think beyond the limits of the tangible and finite world we inhabit. Understanding infinity is crucial for scientific progress. It's integral to theories of quantum mechanics and cosmology, helping us make sense of phenomena from the infinitesimally small to the unimaginably large. It allows us to model and predict behaviors in physics, mathematics, and beyond. It's a tool, a concept, an enigma that propels us forward in our quest for knowledge.